So we'll continue our effort to be funny and say Grampy. Why does a glacier flow? As we said, glacier is not brittle like ice. Ice is frozen water where the molecules get rearranged. It rejects all the salt. So when the seawater freezes because the atmosphere is taking heat out of it, it begins to freeze. Then the salt is taken out. It's called brine rejection, B-R-I-N-E, which is salt water. It's rejected means this ice is formed by rejecting the brine, and the ice has lesser density than the water, so it floats. And as we talked about before, floating ice, floating glaciers can be seen on top, and only thing you have to remember is a glacier is a massive thing and it will have 90% of it below the water. And the Titanic happened. Imagine if the water was heavy, if the ice and glaciers were heavier and they just sank to the bottom of the ocean, what would have happened? Of course, one of the biggest thing is that Titanic would not have happened and we wouldn't have all these Titanic movies. Well, that's a silly joke, but here are some nice figures of glacier flowing down. You can see the high altitudes here are colder and somehow the snow is falling on this side and this side, but here it seems dry because the mountains are undulating, and which way the wind comes and which way the air rises and expands and cools and precipitates. Remember, we talked about the windward side and the leeward side and so on. So on the windward side, facing the wind, the mountain squeezes out rain, and it's called orographic rain, topographic rain, and precipitation and so on. So once the snow keeps on falling and compresses and starts forming a glacier, glacier flows like molasses, as you can see here. And this is another example, a nice cold mountain with lots of bright surfaces and high albedos and the nice clouds behind, and the glacier flowing, and you can see that it's flown into this water body again, which means that it may be floating, or maybe that's the end of the land, we don't know, but in this particular figure. But you can imagine that it's also possible that this glacier is slowly melting and retreating and forming a little glacial lake. And I mentioned the colors before. You can see the nice chemistry of the water that brings in all those special elements which gives this which give the water this amazing color. Some glaciers also have a very blue color because if they are transparent enough, then they reflect, scatter sunlight in ways to, you know, make it look very, very blue, teal, and so on and so forth. And we'll talk about dirty glaciers also in a minute, but this is the point about global warming and melting of the glaciers. And the retreat means basically there is a line, let's say here, where there is more snow falling than the glacier melting. So you have or the glacier melt is just equal to the snowfall and the accumulation. So it's called an equilibrium line. There is an equilibrium between the rate at which the glacier is forming and the rate at which the glacier is melting. But when the ablation of the glacier, or the loss of mass of the glacier as opposed to the accretion of the glacier, or the mass buildup, accretion is accretion and ablation is ablation. If you may be old enough to understand what I'm saying, but just I'm being careful, okay? So this is obviously not an equilibrium line because here the glacier is melting. Maybe it is that this is where the melting and the accretion and the ablation are equal. So it's hard to know without having the details. But here is a dirty glacier, okay? So these are all nice figures from NASA and NOAA and the National Ice Data Center in Colorado and the Antarctic glaciers.org and so on and so forth. So we talked about the albedo. Why is this important that the glacier is clean or dirty? You can already see the difference here. This glacier is relatively clean compared to all this pollution and the soil that's there on this glacier. What's the difference? This is much more bright and reflective than the glacier here. So dirty glacier is going to have a lower albedo than the clean glacier, which means it's reflecting less of the sunlight, which means it's keeping more of the sun's energy, which means it's melting. And when it melts and water ponds form on top of the glacier, the water has even less of an albedo than the dirty glacier, so it begins to absorb more and more energy, begins to melt more and more glacier, and begins to drill into the glacier like this. And you can see that there is some water flowing down here. Sometimes you have waterfalls in Greenland like this, where the water form a lake on the surface. This is a massive glacier, and for some reason locally it got heated and melted, and once it melted the albedo decreased, more energy got absorbed, and it kept melting more and more and started forming these lakes on top of the glacier, and the water starts to bore into the glacier and can flow all the way to the bottom of the glacier. Remember, the glacier can be 1 kilometer, 2 kilometers, 3 kilometers thick, depending on how long it's been growing. If you grow all the way to the bottom, like drill into the glacier like this, these are called moulins, M-O-U-L-I-N-S. It's a moulin is a French word that you can follow up. You may have heard of something like Moulin Rouge, but talk to your parents before you explore those sorts of things. So here is a moulin, and down to the base of the glacier, more than a kilometer deep here. What happens if the water goes all the way to the bottom of the glacier? It can begin to melt the glacier at the bottom, and the glacier is sitting tightly on the surface, and it's not able to slide because it's stuck to the rock bottom. And if you start putting water and melting it, then it acts like a lubricant and can slide the glacier towards the ocean like we saw here, or more better here. So if you start melting the glacier at the bottom and lubricate it, it can begin to slide and then melt faster and faster. So moulins and dirty glaciers are bad news again. Okay, so here is how another process can happen. The glacier can just crack under its weight. So here is some land and the glacier is sitting comfortably, and some warming happens and some water percolates, or simply some other process of melting happens, and the glacier begins to break off, and this piece is now not attached to the main glacier anymore, and you can see some meltwater flowing down here as well. And sunlight penetrates here, begins to melt and crack more, and then smaller glaciers have less thermal inertia, which means they have an easier time melting when you keep heating them with global warming or with sunlight. Okay, so this is how glacier loss is happening faster and faster. We'll come back and look at how we can figure out glaciers from the past. Where can we go and see whether there were glaciers there in the past or not? We talked about the time machine already, where we said as the snow falls and more snow falls, air bubbles get trapped, pollen gets trapped, this kind of dust gets trapped that we looked at, and as the glacier keeps growing, that past information keeps building. I have another podcast where you can go and see how scientists go on this very, very cold glaciers, and they take a drill and drill it into the glacier and get the ice core. It looks like a thick rod, but that's ice core. They carefully take it to the lab and keep it frozen, and then they analyze the little bubbles and they analyze the bands of ice. Why? Because as snow keeps falling and compressing, you can see how many years of snow has accumulated by carefully doing analysis in the laboratory. And they can measure conductivity of the ice to see how much dust there is, and how the dust varies from one year to the next, or one period to the next. Why? Because if there is more dust, as we saw, it means the global climate may have been drier, and then there was less rain during that period. The rain where? Everywhere. In the monsoon region and in the other regions where the rainfall happens, it could have gotten drier, and there was more dust in the atmosphere, and that more of that dust got deposited with the snow and got compressed and into the time machine. So amazing science to be done, and maybe you get excited, you learn how to do that, and you grow up to be a glaciologist, somebody who goes and studies the glaciers, which is an exciting field. You can go back in time with this time machine and say what has happened in the past and what it means for the future, because knowing what happened in the past with warming and cooling can tell you what will happen in the future as we keep adding more and more greenhouse gases. Okay, so we'll learn about past climates next, but let's finish the glacier story first. See you in the next podcast, everybody.